Hello, welcome to the Richmond Java user group. We have Mike Mitchell talking to us about Java 16. He is a backend engineer at Ippon Technologies, focused in Java and Spring. He's a pretty cool dude. I've worked with him very, very loosely. And he's going to talk to us about Java 16. And I will hand it off to you now.
Hey, thanks. Yeah. First off, can you hear me okay? Everything mic-wise good? Okay.
Yep.
Yeah, I was going to give a quick introduction, but I guess that pretty much does it. Yeah, I've been with Ippon for about a year now, working with Capital One. And yeah, primarily working with Java and Spring, Java version 8, which my last job exclusively used too. I'm sure you guys are, your workplace or your clients are probably working with Java 8 or maybe Java 11. So hopefully there'll be a lot of new stuff here that maybe you can, encourage your clients or your workplace to maybe take up. But yeah, let me, just to make sure that this goes out okay, I'm going to turn off my face. And yeah, let's get to it. So before we get to 16, real quick, I should say, so this is going to be focused mostly or entirely on coding changes and coding upgrades that are made between 9 and 16. So we're not going to be looking at, behind the scenes kind of, garbage collection or deprecations, things like that. This is, the most definitely it's not going to take up the whole time. It's going to hopefully give you the ability to, upgrade to these versions or use them on your own and just jump right into the new changes that were made. So real quick, we're just gonna jump to Java 9, if it'll flip. Okay, so this slide is encapsulating 9 and 10. The first three are Java 9. So Java 9 introduced the JShell command line, which if you're familiar with working with Python, you'll probably be able to pick it up really easily. It allows you to execute your Java code without having to create a class or a main method or anything like that. So if you just want to experiment with Java right in the command line, if you're using Java 9, you'll be able to do that. And it also gives you these copy of and two unmodifiable methods. One is for lists and the other is for streams. And this is going to give you, just what it sounds like, an unmodifiable copy of what you pass into it. And it'll throw an exception if you try and, call any add or remove operations on it. Also, if you're using optional, it gives you this helpful or else throw method. So if you want to, throw a custom exception in the case of a non-present object in your optional, you can, more easily do that. And if you're familiar at all with Scala or Kotlin, it also introduces this var reserved type name. So, if you've used it in those other languages, it functions pretty much the same way. It is mutable, but you can more easily have Java infer your types. So as opposed to here, the second to last example there, having to write map, integer, and string, you can just call var or use var from the get-go. And actually, where it says hash map integer string, that is actually not required for that to work. So once you actually start using the hash map, the compiler will be able to tell how you're using it based on your first operation. So it's pretty smart with the type inference there. The only thing is it can't be initialized to null, and that's just needed for the compiler to determine what to do. And for Java 10, that's only going to be able to be used in local variables. So, within a method itself. But that does change a little bit later. I'll get to that here in a second. Then we have Java 11, which gives you some new helpful string methods. It gives you is blank lines. They're pretty self-explanatory. Lines gives you the number of lines within the string itself. Stripped, gets rid of trailing spaces and tabs, things like that. Then you get this toArray method, which if you want to turn a collection to an array, you don't have to write your own, helper method for it. And because arrays they have better performance than collections and are of a fixed size, you might find certain use cases for that. And then also in Java 11, that allows you to use the var as a local variable within Lambda expressions. So if you're working with a stream and you want to use var, you're allowed to do it now in Java 11 in this case. And also you can see in this example in the third photo, the at non-null, you wouldn't have been able to do that prior to Java 11. And then lastly, you also get this Java command that allows you to, well, it's the same Java command that you've had before, but you don't actually have to run Jabac to compile your class ahead of time. So, you can have single file source code and, more quickly, get output from a Java file. So, then we get to Java 12. You get some extra string methods, just like 11. You get indent and transform. These are pretty self-explanatory based on the examples. Indent, you can give an indent to your string. If you give it an indent of 0 or less than 0, it'll just get rid of all indents, from the beginning of each new line. And then you get this transform, which you can throw a string builder into and, call string builders methods and do what you'd like transformation wise. So you can more easily manipulate your strings there. You also get this static mismatch method within the files library. So you don't have to, read your file into a stream or, compare byte arrays, anything like that. You just pass your two files into the static method and it'll return a -1 if there's a match. It'll return the position of the first byte that mismatches between the two files. And it will give you a -1 if they do match. And then you also get this compact number format, which, if you're working with different geographical locations, it'll give you, a prettier string for your UIs or to pass into your database. So you can see here in this example, it can give you, as opposed to 2592 as a string, you get 2.59K or 2.59 thousand, depending on, what you pass into the number format methods. And that's in the Java 12 documentation. So if you ever, would like to use that, it's pretty easy to look up. But yeah, Java 13. This one I really like. So with switch statements, you can have a much more concise switch statement. So beforehand, you would have had to, have, especially between Monday, Tuesday, Wednesday, Thursday, if each of these you needed a different case, you would have to manually do a break. Here you can, within a single line, if you have the same behavior, you can, do your little expression and return immediately false or, whatever you'd like to return within your switch. So, this can, especially if you have large switch statements, this can really condense your code. It's, a lot prettier to look at. Another thing that's really awesome with Java 14 is the null pointer expressions are a lot more helpful. So as opposed to just giving you the line where it occurred, it'll actually give you information about, the context, the type, whether it was a primitive or an object. And, you can see the bottom right, that's the more helpful example. So that's something that I think a lot of people have been asking for a while, and that, people are happy about it, that finally, Java caught up in that case. I feel like there was one more thing I wanted to say. Text block previews were introduced here too, but I'm going to get to that in a later slide because they become a full feature. They were just introduced in 13 as a preview. Oh, it's the next slide. Okay. So yeah, Java 15, you get text blocks, which I'm sure you've seen in other languages. So you can have, code in your strings, or, really complex strings without having to do all kinds of, escape characters and new lines and things like that. The two, primary cases that I think, where you find the most useful are using the backslash here on the bottom, or just, having your the spacing how you'd like it, to make it, while looking through your code, a lot prettier. It also gives you, and Java 15 introduced these two optional escapes, a backslash or a /s for a single space, like regex, but those actually aren't necessary. Those are just more for convenience. But yeah, text blocks with Java 15 here are production ready. So they're, Oracle claims to be trusted. So, and that brings us to Java 16, which I'll confess, originally this presentation was for Java 15, which what I'm about to show you was part of Java 15, but now these next two features are production ready. So I just moved them to Java 16, and the rest of the upgrades that they made were purely, behind the scenes related. So if you'd like to look at those, you can look at the Oracle release notes. But and I also put them here. Yeah. But yeah, some deprecations. They're migrating to Git and GitHub. Things like that. Thread stack processing changes. Yeah, and I'll give you the slide deck too if you'd like to, look more into these, or Google them. But real quick, so the changes with Java 16. So null pointer, the helpful null pointers that were introduced earlier, you had to manually enable those, and as of Java 16, those are enabled by default. And the main things that are added here are records, pattern matching for instance of and sealed classes. So let's get right into that. So this is another thing that Java users have been asking for a long time. So for data objects, especially, primarily ones that you want to keep immutable, you'd always have to, have your getters and setters, your constructor, private final with the variables that you're using. So now, and again, this was introduced in Java 15, but now they're saying it's production ready, so it's to be trusted. You can have here in the middle right, this photo. This is the equivalent of what's happening here in the older Java version. So you just use the record keyword, and then after person, open close parentheses with the variables, which are going to be immutable, passed right into the class definition itself. So it's a lot cleaner way of having, your final DTOs. Another thing is it will automatically provide to you toString and equals and hash code methods. So that's another thing that I wasn't familiar with Kotlin until another Ippon employee just yesterday gave a presentation on it. So it seems like they're really trying to catch up with the other, more forward-thinking languages. And you can still, within the record itself, see at the bottom right example, just the same, add methods, or, do as you please. But so that one, people are pretty happy with. Next one is pattern matching for instance of. So this is meant to remove, boilerplate code that's needed when you need to use the instance of keyword. Mainly the having to cast the variable that you're looking at. So you see the first example, that's the old way. You have to cast employee, and then you're able to access the methods available to employee. Now you can just, the compiler will see that you're the context of the way you're using instance of, and you'll be able to access it from the get-go. The only difference is just now within the condition, you'll have to specify a name for the variable. And that's what's shown in the middle example there. So you just add the employee variable name there at the end, and it'll cast it automatically for you. You can also have conditions within the same line of the instance of, which you weren't able to do before. That's what the bottom example is showing. So if you had tried to do that prior to Java 15, again, this is something that was introduced earlier, but as of 16, it's prod ready. That would have given you a compiler error. So, you get more real estate per line with your coding. So the next one is sealed classes. So this is meant to give you more control and be more restrictive with your inheritance. So in this example, we have a class person, and we're calling it a sealed class that permits employee and manager to extend from it. So this is telling the compiler that no other objects can extend from person. So you have to also specify if you have a class that's extending from a sealed one, it has to be either final or non-sealed. The final is specifying that nothing can then extend from person, and non-sealed is saying that person can have an extension after itself. Another thing is this wouldn't have given you a compiler error, but the bottom example, you can see we have these two instance of conditions. It would have thrown before Java 15 and 16 a compiler warning saying that you haven't exhausted all possibilities here of the extended objects from a person. But now it sees that, because it's sealed class, these are the only possibilities. It wouldn't have given you, or it won't give you a compiler warning anymore. And again, that can be used in Java 15 and 16. And it looks like in 17, that's going to be production ready. And speaking of 17, so these are the things that they're talking about that are coming in either 17 or the future, aside from, more back-end changes or behind the scenes changes. So sealed classes are becoming production ready. This cool thing, I just saw this the other day actually, and added this enhanced pseudo random number generator, which there doesn't seem to be much information about yet, but I thought that sounded pretty cool. It sounds like it's proposed to be coming in Java 17. And then the text blocks and switch expressions are also in 17 going to be production ready. So so that's what's to come. And this is something I found helpful when I was learning about the long-term support versus non-long-term support releases. The difference between the two, between each Java release. You can see here that most of the changes between each version, there aren't very many of them. And that's because for a while now, Java has been doing releases every 6 months. And most of them are non-long-term support releases, meaning that once you get an LTS release, that's something that they're meant to be supporting and advertising themselves as supporting for, the next 10, 20 years. So, Java 8's LTS, Java 11's LTS. I don't think 17 is going to be, but they haven't done one since 11. So they probably will, soon here. But so each one is giving you just like a trickle more of, catching up to other languages and new features that people have been asking for. I think that's the last slide. Besides sources. That's the last one. And again, I can share these slides if you'd like to, play around with, Java locally, or maybe even, incorporate this stuff into your own code. yeah, if anyone has any questions, yeah, that's the end.
Great presentation, Mike. Does anyone have any questions right off the bat? Going once.
So I do have a, yeah, it was great. Thank you. I do have a quick question. Are the how is the tooling around all this? Like, say, for example, IDEs. So have you seen the IDEs being able to support these features?
I'm sorry, ID. What do you mean by IDs?
Like IntelliJ or Eclipse?
Oh, IDEs. I'm sorry.
Yeah.
Yeah, as far as I know, well, actually, the farthest I've used personally is IntelliJ Java 13. I've experimented with, and yeah, I've had no problems with it. And same with using the JavaC and JShell command line tools. Those have been great. But no, that's a good question. I haven't actually looked into the compatibility between IDEs. That's a good question.
I just checked, and Java 16 is supported both by Eclipse and IntelliJ.
Cool. Wow, that was fast, actually.
Yeah, I think a slightly different topic, I think, is what you want to support in production. So I think 17, I believe, is going to be the LTS. That's next LTS.
Oh, it is. Okay.
So yeah, so I think it's good to start playing around with these, but like don't put them in production.
Yeah, I don't think many companies yet would be comfortable with it unless it's an LTS. Yeah,
Right.
Unfortunately, but yeah.
Forgive me, I showed up late and I don't know if you covered this or not. I'm with you. I'm still on Java 8. Is this like, are all these newer versions breaking to my Java 8 code base, or in particular the dependencies that I have to pull in to build a package?
They claim to always be backwards compatible, aside from some of the updates will have deprecations to the libraries, but they still claim to be backwards compatible. But
So
I haven't experienced any issues, but you never know.
Yeah. So in theory, at least in theory, I can leverage the new code features, language features that are there, and not change my Maven POM file.
Yeah, I guess in theory, yeah.
In theory, okay.
Although I would only say if you're coming from Java 8 and you're if it's production, I would only trust Java 11 at this point until 17 is coming in. That's the next LTS. Yeah.
Okay, thanks.
Yeah, I think there are a couple of things to consider in addition to that, like in your question, like around dependencies. Yeah, I think the thing you want to be really careful about is the dependencies don't break.
Right.
I mean, there are some strategies, like you can kind of start, so let's say you're Java 8 code, then you can just try compiling to Java 11 and seeing if it compiles, right? Like, so you can just set the compile target to 11 and see if it compiles, and if not, then fix all the issues. And then you can produce like the runtime binary not binary, bytecode with 11, and then run it and run all your tests against it, make sure it actually can run. So there'll be a 2 or 3 step process to get before you can just deploy it.
Good question, Steve. We'll give it a couple more seconds if there's any last lingering questions.
Yeah, and I see Jeet says that This will be going onto YouTube, so we can probably also just put the slides, within the description there. And there's also a blog post version if you'd like to, more quickly grab some of the code, copy paste some of that directly from the blog post. That'll, allow you to more easily get into this stuff. Yeah.
Okay, well, I guess without further ado, we can call it an evening and see you all next month.
All right. Thank you.
Thanks for coming, guys.
Thank you.